I am R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this lecture series, we see the topic ground wave propagation for the unit antenna measurements and wave propagation. So now the first type of wave propagation is ground wave propagation. It refers to the way electromagnetic waves travel along the Earth's surface, and it is one of the primary modes of radio wave propagation, especially for low and medium frequency signals. So, ground wave propagation is significant for communication over distances where line of sight, that is direct wave propagation, may not be feasible, such in cases where the radio waves need to travel beyond the horizon. So, ground wave propagation occurs when a radio signal travels along a Earth's surface. The wave does not just travel straight through the air but rather follows the contours of ground to some extent. This type of propagation is particularly important for low frequency signals, that is below around 3 MHz, which tend to be observed and refracted by the ground. And it is the ideal radio wave propagation for short distance communication, especially during the daytime, and it is applied to local radio broadcasting, radar, amateur, and radio communications. And in ground wave propagation, the transmitting as well as receiving antennas are often on the Earth's surface and offering multiple paths for communication. So when the transmitting antenna and the receiving antenna are in the line of sight, then direct path exists between them. A wave that propagates between antennas at the line of sight is called a direct wave. The direct wave is a component of grounded wave. And there are three components of ground waves. One is surface wave, the component of a ground wave that uses Earth's surface as the wave conductor, then it is called as surface wave. And next is direct wave, the component of a ground wave that propagates through the shortest distance between the 2 points on the Earth's surface. Third one is the Earth reflected wave. Here the component of a ground wave that gets reflected from the Earth's surface and then travels towards the receiving antenna. And the characteristics of ground wave propagation, the frequency range. Ground wave propagation is most effective at low frequencies, medium frequencies, and high frequencies, which is up to 3 MHz. And these frequencies can follow on Earth's surface for long distances, especially at night when ionospheric effects are reduced. Attenuation. The wave travels along the ground, it experiences some attenuation. We know attenuation is a reduction in the signal, and the rate of attenuation depends on factors like frequency, conductivity of the ground, and the terrain. For example, seawater provides better conductivity than dry land, allowing for more efficient ground wave propagation. And third characteristic is the range. The range of the ground wave propagation can extend up to several hundred kilometers, and this is depending upon the frequency and environmental factors. For every low frequencies, ground waves can propagate over thousands of antennas, such as higher frequencies, and the range is shorter. So terrain impact is also another characteristics. So this type of terrain can also affect ground wave propagation. First, the conductive terrain allows for better propagation, accompanied by in mountainous or highly uneven terrain when the signal is may be obstructed. And the nature of ground waves, especially surface wave, are influenced by the nature of the ground above which the signal propagates. And the ground penetration and surface conductivity are very important when it comes to low frequency ground wave propagation. And the ground penetration at low frequency ground wave is high and affects surface conductivity as well. So polarization is another factor affecting ground wave propagation. The antenna polarization is of great importance in antenna ground wave propagation. Vertical polarization is better suited by ground wave propagation than horizontally polarized waves. So because of the vertical polarization requirement, medium and long wave radio sections generally employ self-radiating vertical transmission antennas. So the weather plays an important role in the losses incurred in ground wave propagation. Dry and sandy signal propagation paths are not suitable for ground wave propagation. So the moisture content in the atmosphere can be helpful to ground wave propagation. And signal frequency, the signal attenuation ground wave propagation is dependent on the signal frequency. As the frequency increases and losses in the wave propagation increases, and this phenomenon limits the ground wave propagation above 3 megahertz. The signal frequency also influences the maximum range of ground wave propagation, and other factors affecting the ground wave propagation is maximum ranges are the density of the ionization of the layer and the angle of influence at which the wave enters the surface. And another applications are AM radio broadcasting, and it is useful for radio signal propagation, navigation systems, low frequency navigation systems such as those used by maritime and aviation industries. And military communication also it is useful. Some military communication systems use ground waves for reliable long range communication in areas, and whether other propagation methods may not be effective, either satellite or sky wave propagation. Assessment: ground wave are always dash polarized. The answer is A, the vertically polarized. Dash ground wave propagation is used for signal up to frequency. The answer is A, 2 megahertz. Thank you.